Right, as you can see, this is component 1 from 2022, and this is question 1. So without further ado, I'll get involved. This A-level mathematicians will recognize this straight away as a kind of ladder problem, but uniform plank this is. Of length 2 meters, width 232, is in equilibrium, so forces are balanced here. Against a wall, we've got the angle from the diagram as well, as shown in this view. The wall exerts a horizontal force H, the floor is rough, exerts a force P on the plank. So you can see that P is at an angle. That is a combination of the normal reaction force and some sort of frictional force. Show the plank's weight on the diagram using a correctly placed arrow. So the key thing here is this is a uniform plank, so the center of mass is going to be halfway along, so therefore the center of gravity is also halfway along. So that is just going to be a vertical arrow in the middle of the weight, 232 newtons, like that. Show that H is approximately 80 newtons, given a brief explanation of your method. There's 4 marks here. So this brief explanation, I'm just going to say that the fact that it is in equilibrium implies that moments are balanced or sum zero about any point. Therefore, if I take moments about point B, the anti-clockwise moment caused by this weight is going to be 232. The weight multiplied by, it's halfway up, so that is 1 meter multiplied by cosine of 55, because remember, it's the perpendicular distance that is necessary. That needs to be equal to the clockwise moments about B, and those clockwise moments are caused by H. If I just do dotted line here, 2 meters long is the plank, and it's times the sine of 55 degrees. Therefore, H must be equal to 232 cos 55 divided by 2 sine 55. Throw that into a calculator and get 81.2 newtons. Bear in mind, for questions like this where it says show that is approximately, you still have to give an exact answer. You don't have to say that, you don't have to then say that that is approximately 80. You don't get anything extra for this bit, but you do have to write an exact answer. It isn't enough to just write that calculation and write approximately 80. Don't do that. You have to show that your calculation does give a correct answer. So the mark scheme, I haven't seen this mark scheme, by the way, but I strongly suspect if we were to look at it now, it would require 81.2, an exact answer. Write down horizontal and vertical components of P and hence determine magnitude and direction. Notice that this is write down, not calculate. So no calculations required for those vertical and horizontal components. And that is because the only horizontal forces acting here are the horizontal component of P and H, and the only vertical forces acting are the weight and the vertical component of P. So those components must simply be equal to those other forces. So PH must be equal to 81.2 newtons, and PV must be equal to 232. Therefore, whoops, that's not a very good P. Therefore, P is square root 232 squared plus 81.2 squared, which is 246 newtons. The direction of P, so I've got P like this, and that is 81.2. That is 232. If I call this theta. Then tan of theta must be 81.2 over 232, and therefore theta is 19.3 degrees from vertical. Okay, the maximum frictional force the floor can exert is 90. Show that the plank could not be in equilibrium at an angle of 45. So if we go back to this expression that we've got for H, the same expression will still be true, it's just that the angle would change to 45. So at 45 degrees, H would be equal to 232 cos 45 divided by 2 sine 45. And of course, cos 45 and sine 45 are equal to each other. So that is just 232 over 2, which is 116 newtons. And 116 is greater than 90 newtons. Yeah. So insufficient friction. For equilibrium. And that's it.